Welcome back from the break. We are going to start Unit 4, which talks about linear functions. Today we are going to cover Lessons 1 and 2. To start with, on Lesson 1, this is describing and graphing situations. We have 3 learning targets for this lesson. Number 1, you should be able to explain when a relationship between two quantities is a function. And the short answer for that is that a relationship is a function when every input has only one unique output, or every x input has only one y output. Your learning target number 2 is that you should be able to identify independent and dependent variables in a function and use words and graphs to represent the function. Your independent variable is your input. It's the one you can change. It's the one we usually identify as the x variable. Your dependent variable is the one that changes based on what your input is. So your dependent variable is your output. It's the one that we normally call the y value. It's what you're calculating. And your third learning target is that you should be able to make sense of descriptions and graphs of functions and explain what they tell us about situations. Problem number 1. The relationship between the amount of time a car is parked in hours and the cost of parking in dollars can be described with a function. Identify the independent variable and the dependent variable in this function. So our independent variable is the one that we change, and the dependent variable is the one that gets calculated. So we have two possibilities here. We have the amount of time a car is parked, and we have the cost of parking. So we have to ask ourselves, which one of these two is the one that we change, and which one is the one that gets calculated? So, if you think about this, do you change the amount of time that you park a car, and then the price is determined based on that? Or do you change the cost of the parking, and then that determines the amount of time that the car is parked? In this case, my independent variable is going to be the amount of time the car is parked, and my dependent variable is going to be the cost. If you were to drive to a function in downtown Providence, you would park your car, and however long you were there would then determine the cost of your parking. For example, if you park at Providence Place Mall, you pull in, you take your ticket, you go inside, you do all your shopping, you watch a movie or whatever, and then when you leave, you put that ticket in the machine. It looks at how long you were parked, and then it determines the cost. So my independent is the time of parking, and the dependent variable is the cost of it. The next part says describe the function with a sentence of the form blank is a function of blank. So the first thing you need to understand is that your dependent variable is a function of your independent. So that means that cost is a function of time. Anytime you see this sentence, your dependent variable is first, and your dependent variable is a function of your independent variable, which in this case is time. Number 3, suppose it costs $3 per hour to park with a maximum cost of $12. Sketch a possible graph of the function. Be sure to label the axes. So, when we do this, we have our x axis and we have our y axis. And our x-axis is our independent variable. In this case, that's time being measured in hours. And the y-axis is our dependent variable. In this case, that is cost. And that is measured in dollars. So then we can label our axes here. I will label time in units of 1 hour. And since our cost is $3 per hour, I will label the y-axis by units of $3. So now if we were to sketch this, if I don't park at all, then my cost would be $0. If I parked for 1 hour, my cost would be $3. If we park for 2 hours, the cost would be $6. If we park for 3 hours, the cost would be $9. If we park for 4 hours, the cost would be $12. And it tells us we have a maximum cost of $12. That means once we hit this point, any amount of time after that is still just going to be $12. And because the time could be partial, but the cost is charged in $3 increments, we're going to leave these points up until our maximum, and then we could draw a solid line. So anywhere between $0 or 0 hours and 1 hour, it's going to be $3. As soon as I go over that, it's going to go up to 6, 9, 12, and then it can stay solid. And then number 4, identify one point on the graph and explain its meaning in this situation. So I could take any point, such as 1, 3, and that point 1, 3 means 1 hour parking costs $3. Number 2, The prices of different burgers are shown on this sign. Based on the information from the menu, is the price of a burger a function of the number of patties? Explain your reasoning. So what you need to understand in this problem is the price of a burger, because that comes first, they're saying this is the dependent variable. This is the output or the Y value. A function of the number of patties. So because this comes after a function of, this is my independent variable or my X value. For something to be a function, that means for every input, there can only be one possible output. Or for every independent variable, there can only be one dependent variable. So if we look, we have one patty, that's my independent, and I have $3.49. That's my dependent. So one independent variable gives me one dependent variable. That would be a function. The next choice, 2 patties, that's my independent variable. $4.09. That's my dependent variable. So one independent variable gets me one dependent variable. Still a function. Now we look at the next one. 2 patties, that's my independent variable. $4.59. That's my dependent variable. But now you'll notice I have the same independent variable, 2 patties, but now I have 2 separate independent or dependent variables. This is not a function, because now when I have 2 patties, I have 2 different possible outputs or dependent variables. If I have 2 patties as my input, I might get $4.09 as my output, or I might get $4.59 as my output. In order for something to be a function, every input or independent variable can only have one possible output or dependent variable. This is not a function. Number 3. The distance a person walks, d, in kilometers, is a function of time, t, in minutes since the walk begins. Select all true statements about the input variable of this function. So, remember, anytime I see is a function of what comes before it, the distance a person walks in kilometers, this is my dependent. This depends on what comes next. In this case, time, t, in minutes since the walk begins. This is my independent. My dependent is my output or my y. My independent is my input or my x. So now we can go through the choices. A says distance is the input. Well, we said distance is dependent, so that's my output. So A is not correct. Time of day is the input. Well, time is the input, but it's time since the walk begins, not time of day. C, time since the person starts walking is the input. That's what matches. My input is the time since the walk begins. So C is correct. D, T represents the input. Time is measured in T, and that is my input. So D is also correct. E, D represents the input. Well, D is the distance, and distance is our output. So E is incorrect. F, the input is not measured in any particular unit. Well, my input is time, and it's measured in minutes. So F is not correct. G, the input is measured in hours. Well, the input is my time, and my time is measured in minutes, not hours. So G is not correct. And finally, H, for each input, there are sometimes two outputs. Well, if this is a function means one input has only one output. That is the definition of function. So H cannot be correct. Number 4. It costs $3 per hour to park in a parking lot, with a maximum cost of $12. Explain why the amount of time a car is parked is not a function of the parking cost. So remember, when we see the words a function of, what comes before it, the amount of time a car is parked, is the dependent. This is the output or the y value. What comes after the words a function of, the parking cost, is the independent. This is the input. or the x value. Now, in order for this to be a function, every value of cost would need to have only one value for time. If we start thinking about this, $3 is 1 hour. $6 is 2 hours. $9 is 3 hours. But now we get to $12. And we find out there is a maximum cost of $12. So as soon as I get to an input of $12, that could be 4 hours, 5 hours, 6 hours, and so on. Because I would have one input with multiple possible outputs, this would not be a function.